All right, so the lesson today is simplifying square roots. So in the past, we simplified square roots by typing it into the calculator to get the approximate decimal answer, or we have done when we have seen something like square root of 25, well, we know that's 5. This is a perfect square. Okay, so before we get started doing some examples, let's take a look at these definitions and properties. So this definition states that when we have the square root of a squared, that will equal a. So let's refer back to the square root of 25. So the square root of 25, we know, is the square root of 5 squared. 5 times 5 is 25. Okay, well, when you have this square and the square root, so over here and the square root, they actually undo each other. They are inverses. Okay, so then we are left with 5, and that's it. And then another property we have here is that when we have two numbers being multiplied, so for example, okay, let's say we have the square root of 2 times 6. Okay, we can separate that as the square root of 2 times the square root of 6. All right, so when we are simplifying our basic square roots, we want to factor the radical completely. Take the square root of any pairs that we see. Okay, and so pairs are referring to up here. So when we have a pair, 5 times 5 is 5 squared. That's a pair. Okay, so taking a look here, we have B1 is our first example. So I'm going to take 1,980 to the side here, and I'm going to make a factor tree. We should have seen factor trees. We worked with them before. And now, as I'm doing the factor tree, I'm just thinking of numbers that I can divide 1,980 by. It doesn't matter which ones you start with, as long as you get it down to its prime numbers. So let's do 10 and 198. 10 can be 2 and 5. 2 times 5 gets us 10. 198, we can divide this by 9 and 22. 9 we can divide by 3 and 3, and then 2 and 11. So these here are all prime numbers. So if we're not really remembering what a prime number is, a prime number is something that can only be divided by itself or 1. So 1, 2, 3, 5, 7, 11, 13, okay, and so on. These numbers can only be divided by themselves or 1. So now that we have it down into our prime factors, I'm going to list it out under a giant square root over here. It's supposed to be an equal sign. So here, I'm going to write them in order from least to greatest. So 2 times 2 times 3 times 3 times 5 times 11. Okay, so those are just all of the numbers from here. All of the prime numbers that we have listed highlighted in yellow, I just wrote them underneath the square root, least to greatest. So now I'm going to combine the pairs. So 2 squared times 3 squared times 5 times 11. Now remember that when we have the square root of a number squared, that is just going to be undone here because it's the inverse. So that means we will have a 2 times 3 on the outside, and then the ones that don't have a square up top, that can't be taken out, are the loners. These ones will stay underneath the radical. So then here I'm just going to clean things up. So 2 times 3 is 6 times the square root of 55. And that is your final answer. Okay. All right. Take a look at the next one. Make our factor tree. 270. I'm going to divide this one here by 90. And 3, you could have divided this one by 10. Does not matter where you start. So here we have 10 and 9. Just finishing up this factor tree here. Okay, that's not 3, that's a 5. All right, so now these are all of the prime factors. So just as we did in that first example, we have from least to greatest 2 times 3 times 3 times 3 times 5. Okay, so now I'm going to write my pairs. Now this is of 2. So we have 2. There's no other 2s. We have 3 3s, but I want a pair. So I'm going to do 2 times 3 squared times that leftover 3 times 5. Now from here, we're looking, where is there a square? Oh, I have one right here. So that's going to undo the square root for just this 3. So we have a 3 out front, and then left hand side, we have a 2 times 3 times 5. Now, got to clean it up. So 3 times the square root, 2 times 3 is 6, times 5 is 30, is our final answer. Okay, and at any time, if you need to pause the video and go back, please do so. So we're going to do the next two together again as well. So factor tree 1,470. I'm going to divide this by 70 and 21. Okay, so I'm just filling out this factor tree here. And then 21, we can get that by doing 7 times 3. Perfect. So then here are our prime factors. I'm going to do the same thing again. Here's my big square root from least to greatest. We have a 2 times a 3 times 5 times 7 times 7. Now we have to write our pairs together. So we have 2 times 3 times 5 and then times 7 squared. With this squared, we know that it's going to undo that square root. So we'll have 7 times the square root of 2 times 3 times 5. Okay, so we'll have 7 times the square root of 30. All right, so let's take a look at the next example here. 1,365. Okay, let's make this factor tree. We can divide this, and I know these are some weird numbers I'm coming up with. I just put this into my calculator and kind of just guessed on things. Now, I did have an educated guess because I knew that it ended in a 5, so I knew I could divide it by something that ended with a 5. So 35 times 39 will get us 1,365. So from here, we have 5 times 7, and this here is 3 times 13. I'm going to list out these factors from least to greatest again. So 3 times 5 times 7 times 13. Take a look. What do you notice here? We have a 3, 5, 7, and 13. We don't have any pairs. So since we don't have any pairs, our final answer is just going to be the square root of 1,365. There is nothing that we can factor out of here. So that is our final answer. Okay, that is it for just simplifying square roots. Now let's go to the next page here. So now we're going to simplify products of square roots. Same exact concept, except now we're going to simplify each square root separately. So we're going to do it all separately. You can do it combining it. You're just going to have bigger numbers. Work smarter, not harder. So let's keep everything separate so we can have our numbers nice and small. Okay, so taking a look at this first example. All right, so over here we have 75. Do a factor tree. We know that 5 times 15 will get us 75, and then we have 5 and 3. Then we have 44. 4 times 11 will get us 44, and then 2 times 2. So over here, I'm just going to write out our square roots. So we have, and I'm going to kind of skip some steps here. I see that we have a 3 and then 2 5, so I know that's going to be 3 times 5 squared. And then times, and I see that we have a 2 times 2, 2 2's, so that's 2 squared times 11. Okay, so taking a look in this first one, we're going to have a 5 times the square root of 3. And the second one, we're going to have a 2 times the square root of 11. Now, the next step here is we are going to multiply the coefficients, and we're going to then multiply the radicals. Think of this like variables. We're kind of combining like terms in a sense here. So the 5 and the 2, they're outside of the square root. So here this will be 10 times the square root of 3 times the square root of 11. Think of that like they're variables. It's a like term here. So then we'll get 33. Okay, go ahead, do the next one. Okay, so the next one here, Same exact process. So we have 65. We can get 65 by doing 5 times 13. That's all we got there. And then we have 80. Here we have 8 times 10 will get us 80. 2 times 5, and then 4, 2, 2, and 2. Okay, so to kind of save some steps here, I'm going to circle these pairs just so I know that we have them. And we have equals the square root of 5 times 13 times the square root, and I'm going to skip some steps here, so 2 squared times 2 squared, because we have 2, 1, 2, 3, 4 2's, times 5. Now, I'm going to approach this one a little differently than the first one. These ones, it's kind of, what do you think will be best for you? So I see what would work out best if I just combined my two radicals here. If I combine them, I will be able to simplify even further and kind of skip some steps if I did it separate. So here I'm going to just combine them. So we have the square root, and I'm going to do it least to greatest. So we have that 2 squared times 2 squared times 5 times 5 times 13. Notice here that we have a 5 times 5. Well, that's a 5 squared. Okay, so then we have here 2 times 2 because the squares undo. And then I know that this will be a 5 squared here. So that square will also undo. So we're going to have a 5 out front. And then our leftover loner is that 13. So he's going to stay inside. So then we're going to clean it up. So 2 times 2 is 4 times 5 is going to be 20 times the square root of 13 is our final answer. All right, next two. And as you're going through, if you feel that you can advance and just go to the next section, you are more than welcome to. Just make sure that you are getting these notes copied down correctly and accurately. So then 20, I'm going to go through this one a little bit quicker. So this is going to be 4 times 5. Then we have 2 and 2. 45, we can divide this here by 5 and 9. And then we have 3 and 3. Okay, so square root of, this is a 2 squared times 5 times the square root of 3 squared times 5. This example again, I see that there's a 5 under both of these square roots, so I'm going to write it down under as 1 square root. So 2 squared times 3 squared. I have 2 5, so that's times 5 squared. Looks like everything is going to be taken out of this radical. So we have 2 times 3 times 5, which will get us 30. Awesome, and then that's it. Okay, a great way to check is punch this into your calculator and make sure it matches up with your final answer. All right, this next one here, just like what we've been doing, make your factor trees. 27. We get this by 3 times 9, and then 3 and 3. Then we have 30. 3, 10, and then 5 times 2 will get us 10. The next one is 26. This here we can do by 2 times 13. I'm going to write the radicals all separate. So 3 squared times 3 times the square root of 5 times 7 times 3. Oh, I did that one a little backwards there. And then 2 times 13. The only reason why I say to do it least to greatest is that you kind of have, it's organized. You're able to see what you're working with. It's not wrong if you do it backwards. It just makes things a little bit more messier. So now I'm going to combine things even further. Okay, so we have this 3 squared here. That's not going to change, but I'm going to write that 2 out front. So this 2 here times 3 squared. And then we have here a 3 and a 3. So I know that's 3 squared. Then we have this 5, 7, and 13. So from here, we can take out both of these 3's. So then we're going to have, oh, am I missing a 2? Oh, looks like I made a mistake here. In this middle one here, this is not, it's supposed to be a 3 times 5 times 2. I could not read my writing. So the 2, 3, and 5. Okay, so my apologies. That is not a 7. That is 2. So then technically we have 2 squared. Awesome. Okay, so then we have here out front 2 times 3 times 2 times the square root, oh that's a 3, of 5 times 13. So then in the end we will have 18 times the square